what section it was. Some sections kind of had 2 or 3 things to them. Some sections only had like 1 thing to them, like writing equations. That was just one part. You go back into 12.4. You think about 12.4 where you had segments and angles. We spent about 4 days in that one because there was so much math going on in there. You get to arcs and chords and stuff. Again, we spent 2-3 days on those. And they all kind of intertwined throughout. But one of the first things that we looked at in circles were these things called tangents. Tangent segments. When you have a circle and you have a tangent segment, it means that it touches the circle at one spot and it's always perpendicular to a radius. The more specific stuff of these tangents came when you talked about in terms of what were called common external tangents. What that meant was you had a tangent, so originated from the same position here, and it was perpendicular to a radius here. The segments that connect from that tangent spot to the circle were always congruent. And if you remember, that was where we showed that it created what's called a kite. That's where the kite definition comes from. And we knew that a kite has 4 sides from November, maybe? A while ago. When we talk about kites, I think it was first semester. We knew that there was 360 degrees within a quadrilateral. You take out the 290 degrees at the radii, and that leaves you, for let's say this is angle A, this was angle B. These 2 angles here and here then were always supplementary. When we did that, you guys remember that you had the segment that connected the 2, and it created right triangles. We did a lot of right triangle stuff out of it. Pythagorean theorem. I don't think we did any stuff. We could have. So you get that. We did those. Also within the tangent stuff, then it started to get a little bit more to the internals, where if you had chords, if you had congruent chords, and that meant that they were always equidistant to the center. If you had congruent chords, then you also had what were called congruent arcs. So if you had the same side chord inside of a circle, you had the same side arcs. And then that led us into one of the first weird-ish style problems that we did. And that was the one where you had the perpendicular to a chord problem. Let me show you. Remember that problem? When we did ones like this, we obviously had right triangles, which means we had to use what? That thing, yes. The Pythagorean theorem. But in order to do the Pythagorean theorem, you had to do a couple of steps to set it up first. What was one of the things you had to do first? Rewrite the radius, okay. Okay, I got us one part. Yes, ma'am. Good. Yep, because remember, when you're perpendicular to a chord, you always bisect the chord. The whole chord was 24, you take half of it, gets you the 12. Exactly. 12 squared plus something squared is going to equal 13 squared. So, beep, boop, beep, doop, beep, doop, beep, doop, beep, doop, beep, doop. Press a bunch of buttons. I'll use the value of b that you were saying, Olivia. What'd you get? 5. You get 5 when you do that. For what? Yes, yeah. 169 subtract 144 is 25. Square root, you get 5. Okay. So it gives me a 5 here. And Ms. Jackson, you were saying, what did we have to get the value of x? And you get? Okay. Bless you. There was a very similar, a very straightforward problem that you had to use 2 parts to it in order to solve. And it comes from the idea that perpendicular to a chord, or a perpendicular chord bisects it, redraw a radius, you get Pythagorean theorem, and you go from there. Okay. Wasn't a very difficult scenario, but it was one that we used a lot. You guys all kind of went a lot of that because you forgot what parts you were looking for. So be careful when you see stuff like this to go back and make sure you know what parts you're looking at as you're going through. Okay. Also, within these, we talked about arcs and angles. It's pretty badly drawn. It's not even remotely. That's close enough now. If I put that one angle there, that one angle gives us enough information to solve for all the angles and all the arcs within that diagram. Okay? Because you've got that setup of things being parallel. So when we did stuff like this, one of the first things we do is say, hey, is that angle outside, inside, or on the circle? It's on the circle. It's on the circle. Okay. If it was inside, it would be one of these angles here. I mean, this one happens to be inside, but it's at the middle. But I could have had an angle that intersected here. This would be an inside one, and I would have to do a bunch of other stuff. But I'm not have one like that. I'll go back to one of those in a minute. So if this is inside the angle, that means the angle is what of the arc that it hits? Half. So what's the arc? Okay. Are there other angles that intersect that same arc? One. The one on there. Correct. Because this one also hits that same mark. Okay. Now, with lines being parallel, you get 2 parallel lines cut by a transversal. Which means, if 2 parallel lines, if this angle is 40, what's? If this angle is 40, what's? Which makes this arc? Okay. How many degrees are in a triangle? Subtract out the 2 40s and you get 100. So if this is 100, what's this? And again, notice that if you're at the center of the circle, you're equal, the same as the arc that you hit. If you're on the circle, you're equal to half the arc that you hit. Yes, sir. Yes, sir. Oh, I don't know about the dozen or so of them that we have in this chapter.
That's why I highlighted.
What's that? Yes, ma'am. No, I don't. When are you going to use this? Pretty much never, but you have to know how to be resourceful to look up and know how to solve a problem. Correct. But then again, you also maybe, if you want to worry about that, then you'd have to contact the state of Illinois. Good luck with that. Yes, ma'am. This, not for this. The formula sheet are like for area formulas. Or any of your area stuff.
Are we getting one?
Guys, please. Miss Jackson, 1 second. Oh, I'm sorry. Central angle arc is going to be 100. Sorry. That's what you get? No? Ladies and gentlemen, you get nothing tomorrow. You have to bring a pencil and a calculator. I will give you a formula sheet for the final. The formula sheet has the areas on it. That's it.
Oh, so not this?
Nope.
So we just have to memorize this?
Yes. Yes. Oh, I'm so sorry. Life is hard. After we did the arc stuff, then we started getting into more of your central angles and the interceptions and things like that. And instead of you having to keep drawing. Or you know what? I have also another idea. If we didn't stare at our phones every 7 or 8, 10, 15 seconds or so, to check stuff, maybe looking back at a problem for 10, 15 seconds, as opposed to seeing somebody, what if they Snapchat me or Google me or whatever. I don't know. And then maybe things would stay fresher in your mind so that way you're not worried about all the outside BS that's out there. I'm pretty sure it is. Anyway, guys, I'm telling you, Algebra 2 is going to be hard. Algebra 2 is going to be very, very hard for this cohort of sophomores. You guys are not going to enjoy it because you don't like to do the work. I'm sorry to say that. It is going to go at a much quicker pace than anything you've seen this entire year, and you're going to be required to do a lot of work. It's going to be assumed that you remember how to solve equations and stuff, and all throughout. They need more than that. Okay? So just an FYI, asking you to do a couple of formulas and stuff now, not going to really enjoy it next year. I hate to say that, but being able to pull stuff up on Slater and just look at how answers are done and writing stuff down without actually doing the work and doing all that, it's great, resourceful, whatever. But you know what? In the grand scheme of things, homework doesn't mean a whole lot unless you're actually trying to do it. Because it's a website that has all the answers to everything.
Oh, I thought it was.
And it's kind of like Google, exactly. But I'm telling you, if you don't know how to do the stuff, and you're screwed. Yeah, it's that simple. I mean, I get it. And you can tell when people do stuff like that and when people don't. Or miraculously, you just have a whole bunch of numbers written down that seem like the right answers. I know who does stuff and who doesn't do stuff. And it shows when you have to perform on your own when you get to tests and quizzes. So there's that. Anyway, take a look at number 2. Number 2 is dealing with one of those bigger problems where you have all your arcs and angles. It also says that values that appear to be diameters are diameters. And I think in number 2 we don't have any. All we have are a bunch of central angles or their intercepted arcs. Which means, what do you know about all intercepted all arcs and all central angles? What do they both have to sum up to equal? 360. Remember, central angles equal the arc that they hit, or vice versa, arcs equal the central angles that are created by them. Yeah, just put them all together to set it equal to 360. So one like this, you've got your 16x, 12x, and 11x, so 16, 12, and 11. What was that, 28, 39? Mm-hmm. 1 plus 3 is -2. -2 and 5 is 105. -2 and 105 would be 103. 103 and 6 is 109. 109 to 95, that is 204. If I'm doing all that correctly. And that has to equal up to 360. Also, it would also be a smart idea if you're standing here doing the stuff to have a calculator next to you so that way you remember where buttons are, especially if we have to use the second answer key, taking square roots and stuff like that. That way you're more efficient at it. Subtract this stuff over, what we get? 39. Is that 196, I believe? No, I'm sorry. I think I was going to 300, so that's, thank you. What is that, 4? And then obviously, more often than not with the geometry stuff, it's not just solve for x. It's substituting back in, and this one was asking for KL. So KL is the 11x plus 6, so what's 4 times 11? Add 6 and you get? Very good. If you look at numbers 3 and 4, what does the 38.4 represent? What does the 23 represent? The diameter. Those are the diameters. Remember on some of the worksheets we've done like that? They don't draw like the bars through it. They put it kind of right in the middle, which means what would you do to find the radius? Correct the undo. If I flip over to 6, 6 is very similar to ones you guys were doing last night. You have the center at -7, -7, and you have a point at -1, -5. It's asking you to write the equation of the circle. And remember, when you're dealing with the center is the h and the k. So if your h and k are both -7s, that means it'll be x minus a -7, but we don't write it like that. We write it as, no, we write it as +7, but very good. Okay, just messing with you. And then when we deal with the radius here, you had to use Pythagorean theorem. And when you're dealing with 2 points, you can do one of two things. You can use the long-winded distance formula to set that up, or just count. How far away is -7 and -1? 6. Remember, that's the change in x. You square it. How far away is -7 and 5? Yes, ma'am. Yes, ma'am. That's the point of doing it that way. And then how far apart is -7 and -5? So your change in x and your change in y. That's the distance formula. That's how you find how far apart two values are. Well, the x values are 6 apart, the y values are 2 apart. 6 squared plus 2 squared is 40. And that's your r squared. There's your answer. Okay. Because the term of the formula is within r squared. Okay. Go to the one directly below that on number 8. You get your quadrilateral, that is inscribed in a circle. One directly below it. And I'm going to write it as 11y minus 4 instead of the -4 plus 11y. I just think it's cleaner. And you get this quadrilateral that is inscribed in a circle. Whenever you have a quadrilateral inscribed in a circle, that means your opposite angles are what? Very good. Now, opposite angles are the ones that are across from one another. That means these two have to add to 180, and those two have to add to 180. So you write it out. 9x minus 12 plus 11y minus 4 is 180. 9x plus 7 plus 9y minus 7 is 180. And if you recall, it sets you up for a system of equations. First things first, you got to combine some like terms. What's negative 12 and negative 4? How do you move a negative 16? You add to their side. So my first equation will be 9x plus 11y is 196. The second equation is 9x plus 9y is 180. Reason being, 7 minus 7 is 0. So, same coefficient, same sign. What do you have to do to eliminate them? Gentlemen, come on, Max, just turn around, please. It's not going to kill you. Let those guys learn. What do? Subtract. So you make 3 subtraction problems out of this. Oops. I always split it up. Oops. So subtract here, 0, 2y, 16. You get y is 8. You get one of them is 8. What do you do to figure out the other one? Substitute back up. Does it matter which one you put it in? Nope. 9x plus 9 times 8 is 180. 9x is 108. X is 12. When we did these things in class earlier, beginning of last week, I want to say, we always made sure that we were using basically eliminations more often than not. I don't see us changing that going into any tests just because it gets to be too messy about the whole algebra stuff. We'll get more and more of that again next year. Let me show you probably which one is the grossest on here, which is number 9. So angle, outside, inside, or on? Outside. So we write it out. Outside angle, half, far, minus close. And those are the arcs. Well, according to this diagram, we only know one of those arcs. We only know the close one. Well, how many degrees are in a circle to begin with? So what's the far one? Yeah. This from here to here then is going to be 360 subtract the 26x minus 5. And notice what I did with the parentheses. You have to subtract out that whole part, otherwise you're going to do it incorrectly. Because the close arc is, in fact, that 26x minus 5. So you're subtracting that whole piece, which means you have to remember to distribute your negatives. I'm not getting to the formula yet. I just know that if this is 12, or let's say this is 100, how much is left for the other side? 260, third time's the charm. So we just took whatever that arc was and subtracted it from 360. Okay. Now going to the formula, we know that the angle, 11x, is half, the far, 360, subtract the 26x minus 5. That's the far arc. And then subtract the close one, which is 26x minus 5. So in this nightmarish problem, you have to distribute twice. And that's the weird part of this. Anytime that your close arc, when you have fars and close, if it's got 2 pieces to it, a binomial, you have to make sure you throw things in parentheses to distribute the negative. That's where you'll screw up algebraically. It'll look like you're doing it correctly because that's what usually they do with the numbers, but it's not because you forget to distribute. So what happens here is, well, I'm going to move this half. How do I move the half? Yeah, divided or multiply the other side by 2. So I'm going to get 22x will equal 360 subtract 26x. What's a negative times a negative? Plus 5 minus 26x plus 5. Because there's 2 of them. So what's negative 26 minus 26? It's negative 52. You're about to say 0. Be careful. Use that fancy little $15 machine on your desk. 370 because 36 plus 5 plus 5. And now you're very fast. Yes, ma'am. Yeah. 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 No, you'd have to do everything. What you would have to do first, if you're doing it that way, you would do all of this part to get to here first, and then take half of it. Okay? You'd have to simplify interior first. That's why, by doing it that way, you're still going to get there, but when something that's this messy looking, just don't do the other side. All right. So how do you move a negative 52? So you get 74, x is 370, and gives you a 5. Okay. The reason I wanted to show you that is because that is probably the worst case scenario of a style problem where you have to really be careful about distributing negatives. Okay? You got to be very, very careful with one like that. In number 10, it's also an outside angles, but it's not even remotely close to as complicated as this one. Because you'll see that your far arc is 37x and your close one is 14x. You don't have to worry about distributing anything. It's just going to be 37x subtract 14x. And it's a nice one. Okay. In number 11, that 8x plus 8, that is the angle V. So that angle is on. What do you do to that to figure out in relationship to the 18x plus 6? Do you double that angle or do you take half of that angle? Correct. You double the angle to equal the arc, or you take half of the arc to equal the angle. Yeah, either one is fine. In 12, you've got your inside, so your inside angle is going to be equal to half the sum of the two it doesn't touch. Sum means what? You add them up. Now, I think in here yesterday, I think we did 15. You look at 15.
Hey, Murphy.
Yes, ma'am.
That's the angle, right?
Yeah, that's it. I think we did one like this in class yesterday with 15. It looked familiar. The other classes, I don't think we did one like this, but I think we did it like in here. This is your tangent segment. You have a tangent segment and an outside hole. So this is the one where you have your tangent segment squared will equal the outside times the whole thing. Well, what is the tangent segment equal to in this case? 18x, which means I put the 18x inside of parentheses in order to square it. I can't write it as just 18x squared. I'm going to screw something up. Okay. You have to put this whole thing is the tangent part. So you got to put it in parentheses. And then you have your outside and the whole thing. 12 plus 15. So when you square 18x, well, that means you have to square 18. Square the x. And now this is why this looks familiar, because I think we had this exact problem yesterday. What do? Nope. Work backwards in the order of operations. Can't take the square root of that one, otherwise you'll screw something up. You have to divide both sides by the 324, and then you take the square root. Order of operations, you work backwards. Okay? And you'll get 1 or -1, but again, in this case, if I use -1 for the x, it won't work because I can't have a -7. I think the other weird one was was like on, I want to make sure you guys saw this. If you look at 13, 13 is also a tangent and an outside hole. On 13 is also a tangent segment with an outside times the whole thing. Which of those two is the tangent segment? It's the x plus 1. Now remember, it's an x plus 1, so it's that whole portion squared. Okay. That has to now equal the outside times the whole thing. Well, what's x minus 1 plus 5? Which means you have to FOIL. Okay? This one you have to FOIL. When you FOIL x minus 1, x plus 4, remember first, outside, inside, last, you're going to get x squared, 4x minus 1x minus 4. Combine them, you're going to get x squared plus 3x minus 4. When I square x plus 1, what do I have to do? Nope, you killed the puppy. Yep. When anytime
Don't say it like that.
Oh, then don't do it like that.
Don't kill a puppy.
Right. So you have to write it out twice, so you won't kill a puppy.
Messed up.
Because you can't. X squared plus 1, or x plus 1 quantity squared means junk squared is junk times junk. You have to FOIL that out. If you write x squared plus 1, or excuse me, if you write down your answer is x squared plus 1, you did the whole thing incorrectly. And that's why it's, Seth always taught it as, if you do it that way, you kill a puppy. Because it's horrible. So that means that you don't want to do horrible things, so you want to rewrite it so that way you don't do that. Anytime you have junk squared, x plus 1 squared, quantity squared, write it out twice so you don't kill a puppy. FOIL it, you get x squared plus 2x plus 1. Ms. Jackson, if you do it that way, you lose your middle term, and you're going to mess everything up. Okay? It is a very common thing that you guys do, so don't do that. And then things drop through. Sir, what's that? Give me a second. I got to finish this. What happens to your x squareds? Yeah. And now it's a really, really easy problem. What do you get for x? 5. Yeah. I will collect the rest of this tomorrow. Wrote up on the board back there in the green where the chat review is in the textbook on 814. The answers to the stuff, if you need extra problems and whatnot, are on the page, was it 1019? It's crazy when there's over 1,000 pages in the geometry textbook. It's good times. But yeah, it's a lot going on here for this stuff tomorrow. We should be able to knock it all out. Come to class ready to roll. We'll start everything as soon as that bell rings, so we got plenty of time. Yes, sir. Not till either Friday or Monday. Yes, ma'am. Yeah. Your inside angle one, let me go back here. Your inside angle is when you have, talk like something like this. The inside angle is half the arc plus the arc. The arcs are the ones that it hits.
So basically, you can just write it out as inside.
Arc plus the two arcs.
So you couldn't just do it.
Nope. That only works if it is the central angle. Big difference. Remember, guys, central angles are different than arcs that are on the inside. Though they're on the inside, they go through that. Okay?
I should just get all these equations tacked
Yeah, even if you do happen to have a central angle. Hey guys, if you happen to have a central angle, and we'll use the example we did a second ago. I think we had one that was 100 degrees here, right? And then if I created this to be a diameter, that means this one here would have been 80, this would have been 100, and this one would have been 80. Do you guys agree? Now, that means that this arc is how much? Okay, which means this arc is. So doesn't this central angle, is that outside, inside, or on? It's inside. So the angle 100 has to equal half of the two arcs that it hits, 100 plus 100. Well, what's 100 plus 100? What's half of 200? That's why central angles equal the arcs that it hits, because it hits the same exact arc. The moment that the moment I move it outside of that, if I move the angle here, it could still hit 100 degrees there, but this down here isn't going to be 100 degrees. This is going to be a different value. That's why the interior angles are different. Right? That's why we say central angles equal the arc. Otherwise, any interior angle is equal to half the sum of the two arcs. Yes, ma'am. Yeah. I don't know. I think so. There's a whole bunch of them. Yes, ma'am. What? Hmm? For again, is that a central angle? Do we double central angles? Did I say if this was 100, did I double it to make that 200? No. Do I double if it's 9x plus 7? No. It's a central angle, so it is the arc that it hits. No matter what, central angles always equal the arc that they hit. No matter what. So, I think I already did. Yes, ma'am. You're so far away.